Nick Seeger. This is me. I work at Engine Yard. I'm one of the members of the JRuby team. And I've been working at Engine Yard for about 2.5 years now. Charles, Tom, and I, we both came from Sun right before they got acquired by Oracle. And we got hired on by Engine Yard to work specifically on JRuby, make JRuby better as a Ruby implementation, and also to improve JRuby and make it suitable for deploying to Engine Yard Cloud. So what actually I have been doing most recently is working on JRuby in the context of Engine Yard's products and making sure that we have a JRuby solution there. So how many of you folks are actually using JRuby today or considering using it? Looks like most of you. OK, great. When I was asked to come out here to give this presentation, it's been a little bit while. I was in San Francisco last October for Java 1. We had a bit of a presence there. Of course, we had our typical Java 1 presentations. And I've kind of been, I won't say stuck, I've been kind of relaxing at home for the past few months. Since then, I haven't had any trips, haven't had any conferences to go through. It's been pretty nice. So when I was asked to come back out here, I was like, well, what should I talk about? And because I felt like, well, I was just back out here a while ago. And I just thought, well, I'll come out and just kind of give an update, and tell you where things are in JRuby Land. If some of you are new to JRuby, some of these things may or may not, you might not have heard of them. You might be missing a little bit of context. And I'll just say, feel free to stop me. And if I can fill in as many details as you want. I'm going to kind of assume that a lot of you have at least a little bit of knowledge of what's going on in the community, and if you don't, I'm happy to fill it in either during the presentation or afterwards. So at Engine Yard, actually what I've been doing is, like I said, working on the cloud product. One of the things I've been working on most recently is a way of using VisualVM to connect to your JRuby processes that are running in the cloud. Anybody familiar with VisualVM? A few of you? Yeah. So VisualVM is this really neat tool that comes with every Java development kit that gives you a really nice kind of introspection into what's going on into the JVM. And so I can start up a Java program on my local machine and start up VisualVM alongside of it. And VisualVM will actually give me a listing of all the Java processes that are running locally. The problem comes is when you have a Java process running somewhere else. And how do you connect to that? And there aren't any real straightforward tools for, say, connecting a VisualVM program on your computer with something off in the cloud. So I went off and worked on this for a while. And I was going to give you a little bit of a demo of it here, but I won't be able to do quite a full-fledged one because I actually don't have internet access. So I'm going to kind of do a little simulation of an app and just kind of talk through what is going on as I do it, just to kind of give you an idea. So the idea with this is that, like I said, you have a web application running in the cloud, and you want to just connect VisualVM to it in a simple, straightforward way. So I have this command line tool. And right now, it's just a command line tool. I'll do it over here. Right now, it's just a command line tool. We could look at making it more full-fledged, maybe a plug-in to the VisualVM program itself later. But for now, it's just a command line tool. So you can run it at your command line. And it gives you a couple different options. Let's make this a little bigger. So the main one is you just say EY VisualVM start. And that's all you need to do. And so in the case of an Engine Yard application, I have a couple of extra convenience features built into the program specifically for Engine Yard apps, since that's, of course, my employer, and I want to make things work well for our cloud. So when you want to connect to an Engine Yard application, you can actually specify the environment or account in your Engine Yard cloud where your Engine Yard cloud application is running, and it will just go directly out to those. You don't have to worry about what EC2 host it's running on, any of those things. So in order to make this useful for all of you, even if you're working outside of Engine Yard Cloud, you can also use it just in a way where you say, well, here's a host that I want to connect to, and I'll specify a port if you want, although you don't have to necessarily. And you can actually have EY VisualVM just open up an SSH tunnel to your host. and then wire things up that way. So what happens is you have a server process that needs to be started to listen on a certain port that VisualVM can talk to. And the way we do that is we actually, you have to run your server process with some specific arguments. And the VisualVM tool will also tell you those. So if you just run it like this with the JVM args, it will print out the Java command line options that you need to use on your server program or your application program. And my system is kind of cold. I'm not sure why it's taking so long here. There we go. All right, so let me just run this one more time. This is somewhat unrehearsed. I prepared all this material just for this for tonight, so apologies if it's, there are a couple of loose, rough edges here. But I'm trying to do this on the fly. So we get these JVM arguments, and what we can do is simply put those in an environment variable called Java ops, which the JRuby command line program recognizes, and it will pass those on to the JVM. So we want to take those, got to quote them. So like that. And then what I have is, to simulate a server application, I have this little program which just runs in a loop. Just a little Ruby program runs in a loop, and every so often, every 10 times through the loop, I'm going to just generate an exception just to kind of simulate maybe a problem that maybe happens periodically in an application that we're trying to troubleshoot, for example. So I can start this program. So I've got my Java, the options set for my server. I can just start this program like that. And so that doesn't print anything out, so I don't know for sure that it started, but it's running. And so then if we go over here and just do EY VisualVM start, it knows to look on, defaults to looking for localhost by default, and it has a specific port that it starts at, so I don't need to specify those arguments. And it should actually start a copy of Java VisualVM, which is coming up now. So you see, so this is VisualVM if you haven't seen it before. One of the things, again, that I mentioned is when you're using VisualVM on your desktop machine or your notebook, you have already have a listing of all the Java processes that are running on your machine. So in that case, this tool becomes superfluous, really. You don't really need it. You can just connect to them directly by selecting them here. I ran it this way just to simulate, well, if this program was running on a different server, the tool, like I said, has that extra smarts to do an SSH tunnel and connect to the host and set the same thing up. So this is what we're simulating. So now, some of the things you can see in VisualVM, if you haven't seen it before, is you have these panels that give you a real-time status of CPU usage, memory usage, the number of classes loaded, the number of threads loaded, and there's a whole bunch of plugins you can install for this as well. One of the things that I've installed is this MBean pane, which lets you examine all the JMX objects that are running inside your JVM. And in particular, JRuby actually installs some of its own. And this corresponds to the one JRuby instance that's running in our VM. If I go look at this runtime thing here, you can see I have some attributes here to specify the backtrace, or that actually keep count of how many backtraces have been generated. We've found over time that one of the source of performance problems with lots of Ruby applications is that it's so easy to capture errors and ignore them and drop exceptions on the floor. The problem is when JRuby in particular, and actually for most Ruby apps in general, generating exceptions and the backtraces that go along with exceptions is rather expensive. So we actually built this statistic into the VM so you can go look at a Ruby runtime and say, oh, well, this thing seems to be generating quite a few backtraces. Maybe we should go try to look into that. And there are some other tools that can help you dig in and actually get specific backtraces and see, well, what code is this that is actually generating these? But this is at least a way to kind of get a quick look and say, yeah, maybe there's some problems here. So that's basically the sort of the VisualVM overview. I don't know if I can do a whole lot more with this brief demo I have here, so I think I'll just go back to my prepared slides and talk about those. That's just one thing to look for. One thing I don't have on the slides here is you can get this code on GitHub. It's open source, so you can take a look at it for yourself, see what I did, see if you want to adapt it for your own uses. It's available under a liberal license, so you can certainly take it out of the existing project or even just use the tool as is. If you want the location of that, it's under the Engine Yard organization on GitHub, github.com/engineyard. It will be in there. If you need an extra pointer, let me know. So another thing I wanted to think about, well, what's new in JRuby is I really wanted to kind of highlight from the community perspective what I think is interesting and new going on and kind of share a couple of those examples with you. Because it's, JRuby is not only about what the core team is working on to make JRuby better. It's even much more, in my opinion, what the community is doing with JRuby. One project that's come along in the past few weeks that I find really interesting is this project called Sidekick. Anybody familiar with Rescue? Rescue is basically a sort of a Ruby messaging queue that the GitHub guys developed. And it uses Redis as the backend store for storing the messages. And so you have your front-end app that posts messages into I think, an array or something inside of a data structure inside of Redis. And then Rescue is a separate process that pulls those messages out of Redis and does your background processing. This guy, Mike Perham, who has developed Sidekick, was playing around with this, and a while ago he was trying to run Rescue with JRuby and finding that it didn't really that model didn't fit. And you think about it, you have Rescue running as a bunch of background processes. You basically need to run one Rescue process for every worker that you want to be able to have doing work. And he thought, well, why do we have to run all these processes? Why can't we just run a single process? And so he played around with Rescue as it was, tried to change it, but then he ended up going off and doing this separate project that just came out. And on this URL that I just posted, he has this sort of tagline here. What if one Sidekick process could do the same work as 20 Rescue processes? And so what he's done with Sidekick is basically implement the same protocol as you have with Rescue. So you can have your front end talk to Redis as if it was a Rescue thing, and it posts the exact same data in the Rescue protocol inside of Redis, and then Sidekick will just read that out, and you can have a single Sidekick process that will just spawn up as many threads as you need to process all your background workers. So the idea is using concurrency and threading as a way of increasing the throughput of your background processes. So I haven't had a chance to play around with it yet, but it looks really neat. What I'd like to do, and I've been trying to do for a while, a common question I have from people who are using JRuby to deploy applications is, well, what if I want to do background processing? What if I want to do some sort of scheduling? Or, there are various tools, Java tools and Ruby tools that can do that. And they sometimes work well in a JRuby environment, sometimes not. What I'd really like to do is something like Sidekick is take it and make it possible to deploy Sidekick alongside a Rails application inside of a single JVM and just have it all just working. Yeah. Another area I find particularly interesting, I've been, being a JRuby person and a Java person, I tend to call myself a polyglot, although I actually haven't really been keeping up much with all the language advances on the JVM, whether it be Clojure, Scala, Groovy, some of the newer ones like Kotlin, or all these different languages. It's getting to the point where it's getting really hard to keep up with all of them, and I generally like that idea that the pragmatic programmers wrote about, where take the time to actually learn something new, learn a new language every year, that whole idea. I'm like, yeah, great, and then the years go by, and I've been doing Java and Ruby for 5 years and haven't really sat down to do any new language stuff. But I feel like I have a background with Emacs and Lisp, a little bit of background in the Lisp world, and I feel like Clojure is a different enough thing by itself that taking two things like JRuby, or Ruby in this case, and Clojure, it feels like there's potential for marrying them in a way where they're different enough as languages technologies that there's not a lot of overlap. They might actually fit together if you like to mix and match tools in this kind of way. And there's actually been a little bit of activity in the community recently around this too. So I actually don't really know much Clojure at all, so I just cobbled together an extremely minimalist example of just creating a hash map and then accessing it. And that's just for the purposes of translating it to the Ruby versions here. So you can see here I'm declaring a variable called hmap, creating a hash map, which underneath the covers for Clojure is actually, it's a persistent data structure, which is a really nice feature of Clojure, that you get that sharing within the data structure without the concurrency aspects of it, where you might overwrite things. So the data structures stay immutable, but they change and share the state that has not changed between different versions of the map. So we're doing that and just getting a key out of it and checking if it has that key. So you have a Clojure file. One thing you could do from Ruby is just say, oh, well, let's just use JRuby's Java integration to just call out to the Clojure command line. That actually works. Obviously it's a little bit clunky. You don't really get any of that tight integration that you really like. You've got your Clojure over here, you've got your Ruby over here. But then again, maybe that's the way you want to do it. You want to keep your Clojure in your Clojure and your Ruby. But there might be some other things you can do here to take a little bit more advantage of Clojure's features without having to get deep into Clojure, the language, if that's not your thing. So this guy, Dave Ray, who I guess is more of a Clojure guy than he is a Ruby guy, came up with this library he called Familiar. And the idea with Familiar was to basically take all the core Clojure functions and make them accessible from Ruby inside of JRuby. So with Familiar, you get some code like this. Well, this is the basic idea. There's a Familiar module in Ruby you're familiar with, and then everything inside of this block gives you direct access to functions in Clojure Core where if you have a dash and then in the Clojure name, it would be an underscore in the Ruby version of that function. So here's our our Clojure that creates the hash map on the top. The Familiar version is on the bottom, so it's almost identical, right? Except we're just using Ruby's variable declaration semantics, and we're calling into that exposed hash map function, which will create the Clojure structure, and passing the same collection as we, in the same format here. And of course, printing out these things, we can do those from Ruby the exact same way. We're just using Ruby's printing methods instead of Clojure's here. So we have that hmap variable, we just print it. The get method is the exact same Clojure get method, except access from Ruby, and likewise with contains. Hedius is actually Charles, one of my fellow JRuby Core members, and he's been kind of keeping his eye on Clojure for a little while too. He thinks there's also maybe a lot to be gotten from kind of mixing the two together. And he cobbled together a library recently that kind of takes another stab at this. And it's still a little bit in its infancy, but it's yet another way to do this. I think it's worth kind of contrasting a little bit. So Charlie's approach was to instead of tying into Clojure Core directly, he wanted to just basically expose the data structure. So we created this Clojure library and all the different data structures exposed through specific classes in the library. And so you access them in a much more Ruby-like way. In this case, if you want to create a hash, there's a persistent map class that has a hash method for constructing. And in this case, you're actually passing in a Ruby hash, and the code underneath traverses the Ruby hash and converts it into the corresponding Clojure hash. One thing and so then you see here below, you get the same sort of Clojure data structure out of it, but you can access the things in the data structure using the Ruby's operator, syntax sugar methods for referencing into the hash or checking if there's a key. And what's interesting about this is it actually is just an artifact of the fact that Clojure data structures implement some of the same top-level Java interfaces. So in the case of these, the Clojure persistent maps implement Java util map, and JRuby happens to have syntactic, not syntactic sugar, but decoration around anything that implements Java util map inside of JRuby. We automatically make it possible to use Ruby hash semantics to do those things. So you pretty much get it for free. What this actually means is you can go back and use the same kind of access method for the familiar version as well.
So what happens if you try to modify the map?
So like if you do hmap bar equals something. Yeah, that's a good question. Should we try it? Might as well.
I know just enough Clojure to know that Clojure will just basically create a new one. So
yeah.
there, the new one's there, and they may well share memory, but that's out of
right.
control.
So let's. Okay. So I do have this code here. I'll post. I have a link in my slides if you want to go check out the way this is wired together. So let's just go grab our. Let's just do this. Familiar. What's that? Hideous? Which one?
That Hideous thing, the Clojure.
Yeah, that's.
And that doesn't depend on familiar, does it?
No, they're separate. Yeah. They're separate. I'm just using the familiar version here. So hmap. So you can see the actual class of hmap as a Clojure lang persistent hash map. And so your question was, what if we do hmap foo equals bar, explodes. So it actually, it appears that Clojure's persistent hash map interface throws unsupported ops for write through.
Yeah, okay.
That makes sense. You know, yeah, I think you can. So let's do this again. So we still have that. We can actually do like, familiar. Yeah, I know what you're talking about. It actually doesn't quite work the way you would want to. So like you're saying, take this, right? Oops, I need to bootstrap that code. Yeah. Right, so we have this hmap, which is an instance of the Clojure persistent map. So the problem is, you know, can we do it like, yeah, foo, like this?
Well, but that's just syntax sugar when you're in 1.9.
Yeah, we're in 1.9 now, so you can do that.
So what do you have in hmap now? Got the gold spec?
Hmap.2. No. Yeah, so his library is a little bit underdeveloped in this area. And notice one thing, that if I try to actually access, actually get an exception here, because he's not expecting it to be, he's expecting the keys to be something that, you know, Clojure would know about. And what's actually in there is a Ruby symbol, and there's no automatic conversion for symbols. So still very much in its infancy. But, you know, it's interesting that comment you had about, you know, what happens. And so that's kind of what I would have expected first of all, but I wasn't sure. So it's kind of fun to see that's actually what happens. So again, with Clojure, you know, if you're familiar with Clojure and the way it does modifications, you use a ref, and then you have to, you know, it's got a software transactional memory system where you have to open a transaction before you modify a variable, in this case a ref. So if we create a ref and we try to set it, do a ref set on it outside of a transaction, we get an exception. But if we use the doSync method, which is Clojure's way of saying, please open a transaction, do the ref set in there, then it works. And that, pretty much the identical code for the Clojure. This is really confusing now, talking about Clojure, the language, and this extension. But basically the same thing here. You can see there's a tiny bit of a difference here. We're kind of using more of an object-oriented approach here, calling set on the ref rather than using a ref set function here. Yep, definitely. In fact, I was going to. You and I were talking about Scala a little bit before we started here, and we do have a little bit of Scala support built into JRuby, so that if you're using Scala classes from JRuby, it knows about some of the special class names for some of the the ways that Scala generates classes under the hood. I'm worried that it's a little bit brittle though, because Scala's compiler changes so frequently that the output it generates may not be compatible with what JRuby expects at the current time.
And the other favorite JVM alternate language would be Erlang.
Erlang, yeah, Erjang, yeah, use Erjang for sure. Yeah. So I have a little short URL here which will take you to the gist that has this code. Which, again, just serves the purpose of showing you how this stuff fits together. The actual code that it's doing is fairly trivial, but at least you'll get an idea. Hopefully you'll be able to get that running. So highlighted a couple of community things. I'm sure there are tons more out there, and if you guys are, know of any that you're currently looking at or interested in, I'd be glad to hear about those too. I'll shift gears a little bit now and talk about from JRuby Core's perspective, kind of what's happening in the core of JRuby. And the answer there really doesn't change quite as much over time. Like it's for the past 6 months or so, it's all pretty much been about the same thing, and that happens to be Java 7. Anybody out here using Java 7 in production yet? Very.
We've installed it at a customer site, but it isn't live yet.
Okay, that's pretty close. We're almost there. Yeah. Yeah, good. Yeah, so Java 7 came out last summer, in end of July. I haven't been deep in the Java world recently enough to know, to remember, kind of like what the adoption cycle is for new JVM, major JVM releases like this. But it seems like Oracle's already burned through 4 updates to Java 7. So it's, the latest is Java 7 U4. It seems like before too long, it seems like it should be stable enough that people can start switching over to it, and hopefully it will. Of course, the big thing for JRuby. Oh, just a quick note. If any of you are Mac users, you're probably aware that there's no official Java 7 release for the Mac yet, but you can actually get a DMG of a preview of Java 7 at this URL, and they actually do have an update 4 build available. I'm not sure how long it's going to take before they stop calling it preview, because as far as I've seen, it just installs and it works. So yeah, maybe it's not the production quality thing that you're concerned about, but most of the people I know are not actually deploying Java software to Macs in production. It's usually deploying to Linux or something else. So it should be good enough for development, and certainly good enough to try JRuby with the Java 7 features. So the big thing, of course, in Java 7 that gets JRuby all excited is Invoke Dynamic. Can anybody tell me what Invoke Dynamic actually is or what it does? Pretty much, yeah. Well, so it was functional in the initial release, but there were some aspects of the implementation that were suboptimal that made things really slow. Yeah, it was like update 2 or 3, something like that. So, yeah. So I mean, now we're definitely in the clear, and all the testing that we've been doing based on the latest Java 7 is proving to come true in that respect. So, there's still a fair amount of, not misunderstanding, but maybe not enough familiarity with what's really going on with Invoke Dynamic, that I thought I'd take another stab at giving you an idea of what's actually going on here, why it's important for JRuby. And I'm going to take a little detour through this really cool blog post that I read in the past couple of months. This guy named Tom Stewart gave a talk at Ruby Manor, I think late last year. It was a conference in the UK. And he called his talk "Programming with Nothing." And hopefully as I talk through this a little bit, you'll see why this is going to be relevant for Invoke Dynamics, but for now, just kind of bear with me. So the idea of this talk that he gave was, what if you had a version of Ruby where all you had in it were lambdas and the ability to call lambdas? You know, you don't have any if statements, you don't have any constants, you don't have any literals, you don't have any strings. Can you actually implement anything? And you know, for those of you who are familiar with lambda calculus and Turing completeness, yeah, you know, you can get there. So, but what's really cool if you go read the post is, you know, he kind of breaks it down in step-by-step detail. And you know, personally, I actually didn't go to school for computer science. I was a double E major. So some of this stuff was a little bit lost on me until recently, but so it's fun for me to go catch up and kind of see, you know, what's happening under the covers. So sort of the crux of the talk is, he talks about FizzBuzz. You guys familiar with the little FizzBuzz test? It's, you know, code like this, right? So here's some Ruby code that implements FizzBuzz. If you loop through a bunch of numbers, and if you have multiples of 5, 3, 5, or 15, you print out different things. And so how would you go about implementing FizzBuzz with just a simple language that only has lambdas and the ability to call lambdas? Well, he actually builds it up. He builds it up step by step. He covers every aspect of this, from numbers to iteration to the modulo operator, the conditionals. And when he adds it all up, you actually get a FizzBuzz program that looks like this. And this is all just, you know, lambdas and calls. You can see that you've got the arrows for the lambdas, and you've got the square brackets are some calling of that lambda. So go check out the blog post to see how that actually matches up. I thought that was pretty funny, though. So the crux of this, right, is that you've got this unit of this kind of lowest common denominator unit of just having a chunk of code and executing it. And the sort of the magic behind Invoke Dynamic is actually basically that same thing. So in the JDK, these are called method handles. And really, a method handle is, well, it is basically a lambda in a sort of way. What actually happens when you're actually running code that uses Invoke Dynamic, JRuby will compile down to bytecode, and when it detects that Java 7 or higher is available, it will generate bytecode that has the Invoke Dynamic bytecode in it. And along with that Invoke Dynamic bytecode, there's a little bit of information. We embed a knowledge of a bootstrap method in the bytecode so that Invoke Dynamic can call over and figure out, well, how do I actually get a method handle to begin with? And so if you think about, you know, a list of bytecode that corresponds to some Java method, you know, inside that method, there's one Invoke Dynamic bytecode that represents one instance of calling out to some piece of dynamic code. So we have to be able to, and that instance is what's called a call site. The call site has a target, which is the actual method handle itself. So the whole process of bootstrapping, which only occurs the very first time that particular bytecode is hit, is just to say, give me a call site and the method handle, construct that whole thing for me, and I'll hold on to it. So the call site will stay static after that point, but the call site can actually have its method handle target change dynamically as well, and the JVM is built to be able to handle that. So the method handles actually look like this. This is a portion of the actual description, abstract class, and of course there's your invoke method. So your method handle is a lambda, and it's got your ability to execute it. So whereas the FizzBuzz program that we saw was extremely verbose because of the lack of additional utilities for building up the logic, method handles actually do come with a bunch of additional ways of sort of composing method handles and decorating them. So you can do things like mutate the argument lists as you call through a method. And there are really interesting ways of combining all these different utilities to implement things like Java try finally logic. You can actually, using these drop arguments and folding and guard with test and catch exception and all that sort of thing, you can actually implement try finally logic completely within method handles. And the other cool thing about method handles, and specifically these sort of quote unquote primitives, if you will, is that the JDK team that have been implementing this stuff have been specifically going down and optimizing the way that these primitives get implemented at the JVM level, so that if you build up a call site specifically just by composing method handles with these primitives, it will get compiled down to really fast code. And that's really the the crux of that difference in the updates was that the later updates, there's more of this logic that's baked in and optimized in a way that you can really boil it down to either machine code or something much closer to machine code than the high-level stuff. So right now, JRuby has several different ways that it uses Invoke Dynamic. Even though you think of Invoke Dynamic and method handles as, you hear the word method and you think, oh, well, it's just for method calls. Well, we can actually use it to implement other things too. Like, we can implement a Ruby constant lookup by just calling through a method handle, or a string literal, or any other number literal. Or like on the last example, math operations. One of the things that slows JRuby down a little bit, and Ruby in general, when you're doing computational stuff, is the fact that we have fixed nums. We have a numeric tower that expands automatically without having to do overflow checking, and it's obviously harder to translate that to fast-running machine code. So what we can do is we can actually look at Ruby code and look for things like plus operators and things that might be numbers adjacent to them, or we're gonna make an assumption and say that is a plus operator for a numeric operation, and we'll just build up that code, generate bytecode for it as if it was a pure math operation. If for some reason we actually call into it, we can have guards around that area that will escape out and drop back to the more dynamic Ruby logic for handling the plus operator. If in fact the actual objects at runtime at that call site turn out to be something other than fixed nums or integers. So we can actually use the Invoke Dynamic toolkit to do faster math. Some benchmarks, of course. Everybody likes benchmarks. Caveat emptor. I actually got these slides from a fellow JRuby committer in Japan who gave a talk just the other day about this stuff. And so I said, oh, great, you just posted some slides. I'll take your benchmarks and pretend that I spent all this time running them. But I think the numbers are still kind of telling. So what you see here is the line across the middle here is the 1.0 sort of the standard, the benchmark. And so that benchmark is JRuby running on Java 7 without Invoke Dynamic. That's right, yeah. So we can run on Java 7 without Invoke Dynamic, or we can turn it on. It will be on by default if you run on Java 7, but you can turn it off with flags just for comparison. And so you see that in a number of cases, just by turning Invoke Dynamic on for things like string literals and math operations, we get more than 50% performance benefit for those micro benchmarks. Now, if you're interested in the code that does these, I can look it up for you. I think it's in the JRuby code base. These are definitely micro benchmarks. It's very low level, just doing a bunch of small operations in a tight loop. So they're not going to apply as much to a real-world program. These benchmarks might give you a little bit more idea of a real-world program where you're actually doing some non-trivial computations with these binary tree algorithms. And again, we see the blue bars is the Invoke Dynamic version of JRuby, where we get almost 50% improvement over without on this AVL tree benchmark. So there's definitely performance benefits to be had, and we get this for free just by using Java 7, just by using Invoke Dynamic, and nothing else. Releases. Of course, what would JRuby be without more updates? We just had 1.6.7 released yesterday. Some of you probably saw that. The idea with the 1.6 releases has been that it's been a sort of our way of kind of keeping up to date with either problems that the community has been having or compatibility bugs that are kind of preventing people from continuing to deploy JRuby. Because the JRuby master branch, the 1.7 version of JRuby has been drawn out for quite a while now. I think it's probably going on 9 months or so. And it's still not quite ready. We've been using the 1.6 branch as a way to roll out additional bug fixes. And so every new bug fix release, we say 1.6.7 is going to be the last version of JRuby in the 1.6 series, and then we find another bug. So for 1.7, we're actually looking at it's probably still a couple of months away. I think there's the master has been pretty stable for a while, but there's still some things we want to clean up. So it's still a little bit off. Yes, yeah, exactly. So we haven't actually talked together and agreed upon a date, but I'm just going to stick my neck out and say that maybe we'll have something approximating at least a 1.7 beta or early access release in May or June sometime, exactly right in time for JRubyConf. And so if it gets to be that time, come poke us and make sure that we get going on it, because it's really easy for the core team to just kind of be heads down working on things, and then suddenly our heads come up and it's like, oh wow, it's been 3 months and we still haven't put out a release of master. So it's really easy for that to get drawn out.
That means Christmas for RVM.
Christmas, yeah, right, yeah. I want to just mention again that if any of you guys are using JRuby itself or some of the projects around JRuby, and if you have any interest in doing some open source stuff, they're always welcome contributions. And I find lately that my time has become more compressed and less available to do maintenance of the projects themselves. So if you have an inkling, please, you're always welcome to join us. Go to just the GitHub page for JRuby, and we have all the projects there. And then, of course, the conference. So we're having our 4th annual JRubyConf this year, and it's happening in Minneapolis. And it might seem like a little bit of a hike for you guys out here. Sorry about that. It's a little bit closer than DC last year and Ohio the year before that. Of course, we're having it in Minneapolis. That's where Charlie, Tom, and I are all based. And we kind of just had this idea that, yeah, we should have a conference for JRuby in our hometown. So we're looking forward to playing hosts. So if any of you guys feel like joining us, we're having the conference at the Guthrie Theater, which is a sort of an internationally recognized piece of architecture right on the banks of the Mississippi. Should be really nice, a great venue. We're going to have whiskey and beer at a conference party, and hopefully lots of other good things planned. We've just started announcing speakers at the website. You can go there. We're going to continue to announce more content as we go forward. I'm having a lot of fun actually putting on the conference planning hat myself, and I've been the conference webmaster as well, which has also been kind of cramping my availability in terms of things I can accomplish, but it's another way of doing things. So as far as that's the end of my prepared material. I just want to close the talk here by saying, I kind of started out thinking about how to present this talk, and answer the question, well, what's new in JRuby? And again, I want to emphasize that really what's new for me is just a tiny piece of it, and I really want you guys to fill in and tell me what's new for you, because it's more than likely something that I'm not familiar with, or if it is, maybe it's something that is a crucial piece of feedback that could help us make JRuby better, or help the adoption increase. And I hope that as these meetups continue, whether or not they continue every month, I'm not sure, but I'm hoping that maybe some of you guys will step up and maybe present a quick story about your JRuby use down the road as these continue forward. So I'm not sure how we're doing on time, but I'll certainly be around for a while yet, and be happy to talk with you guys and just talk JRuby or talk whatever you want. So thanks.
Thank you.